Hello everyone, let's go for the part 3 of our program. This time we are going for the basis of design, this part 3. Okay, so we did this two previous part before, so I recommend you go and watch them before we continued here. Okay, so different between partial factors. As you know, Eurocode is for Europe, but if you move from one country to another, you will find some small differences. Okay, some country use different design approaches. Okay, design approach 1, 2, 3. But once again, this is the first generation of Eurocode. The second generation of Eurocode is maybe completely different. Not completely, but there are a lot of changes. Okay, so for the first generation of Eurocode, for example, you have this color code showing you what approach each country uses. Okay, for example, you have here number one, approach number one. You can see Iceland, UK, Portugal. These are country using this and this one, using this, and even Belgium. Okay, so number two, Spain, for example, Poland, Germany, using design approach number two. So, and the design approach number two also, I think we did explain all this in the previous program of Eurocode. Please check on the YouTube channel, everything is there. Okay, so design approach number one has two combination one and combination two. Okay, design approach number two is there are two possibilities: applying the partial factor on the action and resistance or on the effect of the action and resistance. And then we have design approach number three. Okay, so the value of the partial factors are different in here. A for is for actions, M is for material, R is for resistance. Okay, I think it is written here. A1 to 2 is factor on action or effect of action. M1 to 2 is factor on material properties. Okay, for example, you apply the partial factor on the uh, friction angle or on the undrained shell strength, this kind of parameter, soil parameter, material property, and R1 to 3 for resistance. Okay, for example, bearing capacity. Okay, so anyway, we did all this in the previous program, so please go back and check. But just as a reminder, so in detail, these are uh, the value of partial factor. For example, for the design approach number one combination one, number one combination two. Okay, for design approach combination one, design approach one, combination one, these are the value of partial factor. You can see here A1, M1, R1. It is here A1, M1, R1. A1, A for actions. Okay, you can see here 1.35. This is partial factor for permanent and non-favorable actions. Okay, this means you will take the action, the value of the action. When I say action here, it is load, and you divide it by this value, this 1.35. Okay, if the load is respecting this condition, permanent and non-favorable. But if it is permanent but it is favorable, then you apply just one. You don't reduce it. But here, actually, you multiply, not dividing. Okay, you multiply this value by the load by this value, for example, just to increase it. This is standing as a safety factor. Okay, for those who understand this already, maybe this can be a little bit boring, but for those who don't understand, it's better to explain. So for variable load, non-favorable and favorable, this is what you are applying. So you multiply the load by 1.5. Okay. So this for action. For material, for example, for sharing resistance, cohesion, under shear strength, and confined compression strength, okay? The material M1 is saying you apply just 1. You divide the material by 1. So the way it works is for the force or load coming, we multiply it. Okay, for example, we multiply, these are for multiplying. But for the resistance, we divide it. We divide by this value. Okay, so and the bearing capacity resistance, like bearing resistance for shallow foundation, for example, and sliding resistance and F resistance, you apply 1. R, you see R here, R1. Okay, and now for the approach 2, now you apply the value A2. So A2 has this value 1, 1.30. Okay. When A1 here is 1.35, A2 is 1. Okay. Here is 1, 1 here as well. And M2, here it was M1, M2, it is this. M2 has different value, but for M1, all the material property, it is 1. It means not applying at all. There is no safety at all. There is no margin at all. But here you have this margin for a shear resistance, the tangent actually, and for effective cohesion, 1.25. Okay. And 1.4 for undrained shear strength and unconfined compression strength. Okay. Unit weight also is 1. That one is, you should not even touch it. Something like that. And resistance is 1. Okay. So this is R1. You can see then what is the meaning of A1, M1, R1. For example, here is A2. Okay. The same value of A1 here are A1 here. It means for design approach number 2, when the partial factor are applied on the resistance, you will have A1 similarly to this one, A1 here. Same value. Okay. But M1 also same. Okay. So roughly, this is me going in detail, really. Okay. This is design approach number 2. You can read by yourself the value of each parameter. Okay. Design approach. So here is a comparison between the different, the partial factor proposed by Eurocode and the UK national codes. Okay. So this one, for example, you have uh, this, I think, is the reference before, it was even before Eurocode, Eurocode 7. So you can see the traditional design. They have 3 approaches. One, A, B, C. Okay, A is for like moderately conservative, worth credible, and most probable. So you have the value for partial factor for G, K, all of them. These are similar as you can see in the previous slide. I will go back to show you these value, these factors for uh, where is it? It is here, okay? This one, the value of this, and gamma phi, gamma c, okay? So this is what we have. This one is for the undrained shear strength. This one is for the cohesion. This one is for the friction angle. This one is for a variable load. This one is for the permanent load. Okay. So you have this for ultimate limit state, but for serviceability limit state, this is what we have, A and C. Okay. Just one. Then Eurocode, the national annex of UK, is proposing this. And if you check, you will see that the design approach is design approach number one. If you go back in the previous slide, design approach number one, you will see that these parameters are exactly the same for combination one and combination two, okay? Because UK is using only the design approach number one for this kind of retaining wall, okay? For retaining wall, UK is using design approach number one. So two combination one and combination two. You don't need to do the other design approach in UK, okay? For ultimate limit state and for serviceable limit state, all the factors are one. So this is just a small comparison for mainly for people in UK, because as I said from the beginning, this program will focus mainly on the Eurocode application of Eurocode in UK. Okay, next point we are going to discuss here is unplanned excavation. So sometimes you don't plan excavation, but it happened. So you need to consider this safety in the design. Okay. So Eurocode is clearly recommending to allow some excavation to happen, even if it is not planned. Okay. For that, you have to consider that in design. And this figure will help us, he will help us to illustrate what I'm talking about. This delta H, you can see this distance. For example, the current level of the excavation is here. But in your design, you should consider that, okay, maybe by accident, something may happen and the excavation goes this dash line, the new dash line. Okay, so it is saying that you should consider this delta H. The value of delta H should be like this: H divided by 10. It means around 10, 0 0.10, 0.1 times H, value of H. What is H here? For this case of situation where there is no support, H is the retained height, this height completely. Okay, but when you have this kind of support system, okay, this point and this point here, H is this height, the height of this the lower support, the lowest support, this H. So it means when you have support, then you don't need to consider the unplanned excavation too much. Okay, you don't need to worry about too much. But if you don't have, you have to consider. So it means in the design, the actual height of the the retained soil or the actual H is this one. But in your design, you have to consider H plus delta H. Okay, this is the meaning. But it should not be larger than 0.5 meter. Okay, you have to respect this limit also. It's normally this, but the maximum is 0.5 meter. Okay, we don't want to exceed that unplanned excavation. Okay, but this delta H value uh, can even be even larger than this when you are not certain about surface level. You are not sure about surface level, but sometimes you can even ignore it. Okay, if you have really reliable control measures, okay, during the construction, because this unplanned excavation happen mainly during construction. When you are constructing some digging may happen around here, but you didn't plan before. for example, digging to put some pipelines, this kind of thing, that was not planned at the beginning when the plan was made. Okay, but if you are sure, then you can just ignore it. But sometimes if you are not sure about this limit, you can just increase also, no problem. Next step, selection of water level, because even if the area is dry sometime, water, we have rain sometime, rain, and without the retaining wall, maybe the water would just be traveling easily. But if you put the retaining wall, it's like you may block the road of water, so water may accumulate, and in that case the wall is not supporting only soil material, but it will support also the water. Okay, so for that, you have you have to estimate the water level in your design. Okay, so it's very important to consider that. Okay, retain wall, the design, Eurocode is asking to assume water level above the excavation level for low permeability soil. It means when you are dealing, for example, with clay, you have to assume that there is water above this line, this excavation level, above the formation. Okay, so if you have very good drainage, okay, if you have reliable drainage, then uh, you can consider it below the wall top. Okay, but if you don't have drainage, you should consider water level at the top, at the surface, okay, here. But if you have good drainage, you may consider the water level below here, below the wall top. But when we say reliable drainage, because drainage is just uh, to remove the water behind the wall, okay, make a road for the water to escape. But if you don't have drainage, then you need to consider maybe water level up to maximum here, which is really too conservative, because we know that this is not really actually real. Okay, but when we talk about the reliable drainage, we are not talking about weep holes. Okay, these holes, these kind of holes, you may see these holes sometime uh, on the wall, on the retaining wall. This kind of wall, we don't consider this as reliable drainage. Okay, we are talking about very specific drainage that can take water away. Yeah. So about the British code now, the current practice of British code recommendation is to obtain DW. DW is the height of water. Okay. Okay. When the drainage is not there, there is no drainage. Okay. So the H divided by 4. H is this H. Remember, it's written here. H is the wall's retained height. So this H divided by 4, you take it as the water level. Okay. Then you may then know the water pressure, because the objective of finding the water level is to define the water pressure on the wall, so that you can know that the wall is retaining not only soil but also water. Okay, H divided by 4, but this is in the case of H less than 4 meter. If H is higher than 4 meter, then the limit is 1 meter. Okay, consider the height of water, but it should be above this line, like 1 meter. Okay, so this is what the British Code is recommending. The depths of water, okay? So from the ground to inside, so it is like that. So if H is smaller than 4, it means the depth is like smaller than 1, right? That if H is like 4, then the depth is like 1, and H larger than 4, the depth is maximum 1. So now dw is depth, okay, from the surface to the water level. Okay, next we are going to talk about wall friction and adhesion. We need that also to design the wall, okay? So for the wall friction, we will talk about this angle, the angle of wall friction, small delta, delta D. D as design value, okay? Design value, not characteristic value. So here is the equation recommended by Eurocode. K multiplied by the phi, the design value of phi. Phi is like the shear resistance angle, okay, at constant value, constant volume, okay. So the value of K now will determine the value of the friction angle, okay. For steel sheet pile supporting sand or gravel, then you can take the value of K as 2 divided by 3, 2/3, okay. If now you build the concrete wall in place, okay, if it is cast in place concrete wall, then K is 1, okay, consider this K as 1, simply like that. So this is the friction between the soil and the wall here, okay. So there is no guidance because we are talking about adhesion here also. There is no really guidance uh, in this eh, for a adhesion in Eurocode, because when you check, and we will see it later, the Annex C of Eurocode Part 1, Eurocode 7 Part 1, the Annex C is not including anything about adhesion. So it means it is ignored completely, means zero. But in the UK the national annex, they included this kind of thing, and we will see it in the next section, next lesson, okay? So it is just included in the equation of for stability, simply like that, okay? So this value, for example, the value here of the friction, wall friction, you see the K 2.3, 2 divided by 3 or 1. This value, they may be even lower when, for example, you have the wall supporting some load, because also some walls are supporting load, okay. Then you may reduce this value, or sometime if you have some coating on the surface, then because coating uh, is not really rough, it is like making it smooth. So when you have that also, you should consider decreasing the value of the friction, okay. Yeah, so sometimes some people completely ignore it in that case. If the wall is supporting load, or if the wall is uh, has a coating on the surface, okay. So, and sometimes people even take it like as negative value. Let's keep this here, this equation, remember, for the the wall friction. Okay, so here is a comparison between the Eurocode and some traditional practice for this wall friction, the value of this wall friction. You can compare it by yourself, but you have the here Tezagi, some references for steel. Steel, if the wall is made of steel, for active and passive pressure. We will come back on this active and passive, okay? Don't worry. But you can see the value. It means the active and passive simply for now, just retain that is like different side of the wall. Okay, I will go back to show you. For example, this side of the wall and this side of the wall. So we can say this is active and this is passive. So between this side of the wall and the soil, what is the friction? Or between this side of the wall and the soil, what is the friction? This is why you have active and passive. Okay, but anyway, for each reference, these are the value proposed. Okay, this is in UK for any type of wall. For steel, piling handbook. For steel, they usually ignore the active one. Just consider the passive one. And British standard for any type of wall. Okay. Canadian Foundation Engineering Manual. They have steel, concrete, cast concrete, and precast concrete. Okay. These kind of values changing range. And this is what Eurocode recommends. Okay. Do you remember for steel, it was this value for both sides. Okay. And for cast in place concrete, it was 1. Okay. K, the value of K was 1. That's why you don't have any coefficient here around the 5. And for precast concrete, it is this value. So comparison. So for us, this is what we are considering, because this is Eurocode 7 and this is the UK National Annex. Okay, so these are value are what we will consider in our design. So I think that all for this part. Thank you very much and see you next time for the next part of this program. Thank you.